Good morning, teacher.
Good morning. Good morning, grade 7. This is a continuation of our discussion topic. We are now in the law of reflection. Okay. Can you hear me clearly, everybody?
Yes.
All right.
Yeah.
The law of reflection states that the angle between the incident wave and the normal incident always equal to the angle between the reflected wave and the normal. So it means to say that the angle of incidence, this one, is equal to the angle of reflection or reflected angle. Okay. So if you're going to look at or you're going to try reflecting light in a mirror, you can see that upon checking, the angle of incidence is equal to the angle reflected by the light. Okay. Refraction. This is different. Why? Because refraction is a change of direction of a wave as it changes speed, moving from one medium into another. So when you say change in direction of a wave, okay, it could be a change of speed. It could be a change in motion from one medium. When I say medium, this is anything that is actually used um, by waves in order to move. By the way, let's give a brief recap of what we did last meeting. Almost all of you are actually absent last meeting. But to give you an idea, there are two types of waves. Okay. The first one is the mechanical wave, which uses medium in order to travel. The second one is the electromagnetic wave, which didn't actually need to have a medium to travel. Okay. One good example for mechanical wave is your sound. Okay. Your sound cannot travel in a vacuum. Are you familiar with a vacuum? Anybody?
Yeah.
This is an area wherein there is no medium, no air, no wind, um, no water, nothing in there that can be used for the wave to travel. Okay, just like space, just like a black hole, those are vacuums. Okay. Upon checking, there are really a lot of you are present. I need to go back to the first slide simply because this is a continuation of the discussion, and you need to know also the introductory part, the lesson. Okay. Waves always begin. By the way, our topic is wave, light, and sound. This topic, to give you an idea, is really broad. We're talking about waves. Um, we're talking about electromagnetic waves. There are a lot of electromagnetic waves. We're talking about some law of refraction, law of reflection, and those are integral part of the lesson. Waves always begin with a source of energy that causes a back and forth and up and down disturbances. Okay, waves are disturbances or movement. A wave is a disturbance that transfers energy from one place to another without transferring matter. Okay, just like when you shout. So you are actually in your place, but then again, you transfer wave. Okay, your other friends can hear you shouting because your sound wave travels towards their ears. energy transfer. When you lift a pebble, are you familiar with a pebble? Pebble? You transfer energy to yes. Suppose you drop a pebble into a pond. Okay, when you lift the pebble, it is against gravity. Okay, and you actually transfer energy to it because you're acting on it. You're acting on the gravity. Okay, the laws of motion by Newton. It is the law of what? Inertia. Okay, you're acting on the body. From potential energy to kinetic energy. And then you drop the pebble into the pond. The pebble's energy transfer to the water. Waves carry the energy away from the point where the pebble hits the water or hit the water. The water itself move up and down as wave passes, but the water does not move along the wave. Okay, just like um, just like when you drop a pebble, you can see actually some movements of water. Okay, that is actually one of the example of some disturbances or and energy transfer. You're the pebble there, diba, when you lift it, you exert some energy. Okay, you transfer the energy to the pebble. Once you drop, again, gravity pulls it down to 9.8 meters per second squared, and energy transfers to the water. There are two types of waves, or main types of waves. Some waves carry energy only through matter. Other types of waves can carry energy through matter and empty space or vacuum. Okay? Let's tackle first mechanical waves. A wave that travels only through matter is a mechanical wave. Yes, from the root word mechanical. Okay? Mechanical. A medium is the matter through which mechanical wave travels. Anything that a wave used to travel is a medium. That's a singular. When you the plural form of medium is media, multimedia. A mechanical wave forms when a source of energy causes particles that make up a medium to vibrate. For example, a pebble falling into the water transfers its kinetic energy. Remember that when you pick up those pebbles, you actually convert the energy from potential to kinetic. Kinetic energy to particles of water. By the way, are you familiar with potential energy and kinetic energy? Any idea? Grade 7? Chat box. Okay. When we say potential energy, this is energy at rest. Just like your keyboard will not touch. Okay? When it stays there, it has actually potential energy on it. Books on the table, those are with potential energy. But once you touch it, you disturb it, the law of inertia actually applies to it. So you convert the potential energy into kinetic energy. Okay, kinetic energy is the moving energy. Okay, let's move forward. Okay, just like this one. When you drop a pebble, you can see that there are a lot of waves traveling from the source. This is the source, right? And the waves are traveling away from the source. But water is not moving towards it. Okay? It's just like the energy from the pebble transfers to the water and away to the source. The second one is the electromagnetic waves. Okay, a wave that can travel through empty space or through matter is an electromagnetic wave. This type of wave forms, by the way, chair, Can electromagnetic wave travel through matter or a medium or a media or different media? Yes, they can. But they can also travel through space or vacuum. This type of wave forms with a charged particle such as electron vibrates. For example, electromagnetic waves transfers the sun's energy to Earth through empty space. What do you call the sun's energy? That travels to Earth, making the Earth warm, hot, and the reason why there is an occurrence of climatic conditions or climate. Anybody? Anybody? Okay. The Earth's or the sun's energy is called ultraviolet rays. Di ba ultraviolet rays? The one that can actually cause sunburn? Ultraviolet rays ba? It is from the sun, right? Okay. Ultraviolet rays or UV rays has radiation. Okay, that causes your skin to have what? Sunburn. This wave is one of the example of an electromagnetic wave. Okay? Once the wave reach Earth, they travel through matter. They travel to your skin. They travel to your houses. Okay? Such as atmosphere or a glass window at your house. So, your house there, your glass window, are considered as the medium or media. But they travel through space. Okay, these are the EM waves or electromagnetic waves. Okay, we have radio waves from your televisions, radio phones. What else? Radios. Okay, they're using radio waves. Microwave ovens. What else? Um, Scanners. They're using microwaves. Infrared. Okay, infrared actually used by some devices and even digital devices, remote controls, television sets, they're using infrared rays. Visible light, this is actually one being used in order for us to see. Without visible light, there is darkness. You cannot see anything. Ultraviolet rays. This is actually from the sun, the one that I'm telling you a while ago. Okay? Ultraviolet rays are from the sun. It can actually travel through space and actually travel through matter just like your skin. Okay? It can cause sunburn. X-rays. X-rays are used in medical because they can penetrate through the skin and they can actually um, penetrate on your bones to scan on your bones. Okay? Gamma rays. This is the strongest among the electromagnetic wave simply because gamma rays are used for medical treatments for cancer. Aside from that, gamma rays also can actually change your genetic characteristic or your genes. It can make your genes mutate or it can make your cell mutate. Okay, let's tackle more about this in the later part of the lesson. Those are just introductory. Describing wave on motion. Okay? Some waves move particles of a medium up and down or side to side, perpendicular to the direction of the waves or wave travels. Let's have transverse wave. What is with transverse wave? A wave in which the disturbance is perpendicular to the direction the wave travels is a transverse wave. Okay? To give you an idea, your electromagnetic wave is a transverse wave. It is actually moving perpendicular to the direction the wave travels. Okay? Electromagnetic waves are transverse waves. Yes, correct. The electric and the magnetic disturbances are perpendicular to the motion of the vibrating charge. So, up and down. Okay? This is a transverse wave. As you can see, the movement is perpendicular as it travels. Okay? It is perpendicular as it travels. Now, these are the parts of the wave. As you can see here, the topmost, this one is called crests. The upper part is crests. The lower part is throw. The distance between the central axis and the crest, or central axis and the throw, is called amplitude. The distance between crest to crest and throw to throw is called wavelength. Okay, again, the upper part or the topmost is called crests. This one. The lower part of the wave is called throw. The distance between the central axis, this is the central axis, towards the crests or towards the throw is called amplitude. The distance between crest to crest and throw to throw is called wavelength. Am I making that clear? Grade 7?
Yes.
Okay. Let me check on the chat box. Okay. Longitudinal wave. This is the second wave. Okay. A wave that can make the particles of a medium move back and forth. This is in connection to the movement, by the way. Okay. Sure, how about the mechanical and the electromagnetic? Those are the types of waves. Okay. This is in connection to their movement. How do they move? Okay. A wave that makes the particles of a medium move back and forth to the direction the wave travel is called a longitudinal wave. Okay. Longitudinal waves are mechanical waves. Yes. Like a transverse wave, longitudinal wave disturbances passes energy from particle to particle in a medium. Okay? Just like this one. Okay? Longitudinal wave actually travels in a longitude motion or back and forth. So just like one good example is your spring. Okay? Diba? When you move the spring, it is actually moving back and forth. Okay? I have a toy before. I called my toy a magic spring. Why? This magic spring can actually move from the top of my stairs going down by itself. Okay? Magic springs are one of the example of a longitudinal wave. Okay? So when you move it back and forth, the energy actually travels from the source going towards the end of the spring. Okay? It is one good example of a longitudinal wave. Do you have any questions so far? Anybody?
And
Okay. Again, in the longitudinal wave, when you move it back and forth, some of the areas there are refracted or refracted. Some of the areas there are compressed. Okay? There is compression and rarefaction happening there. Okay? Compression is to make it short. Rarefaction is to make it stretched. Okay, so there is it. The comparison. This is a transverse wave. Okay, as you can see, the movement is perpendicular. This is up and down. So it creates a motion. It creates now your crests, throw, and amplitude. While your longitudinal waves is moving back and forth. So you are actually creating refraction and compression. Waves in nature. There are a lot of waves in nature. Waves are common in nature because many different energy sources produce waves. Two common waves in nature, 10 minutes more. Two common waves in nature are water waves and seismic waves. Okay? Water waves. Although water waves look like transverse waves, water particles move in circles. Let's take a look at why water waves moves in circle. Water waves are a combination of transverse and longitudinal wave. How? Water particles move towards or move back and forth or backward and forward. They also move up and down. Okay, because it is moving back and forth movement and up and down. So it is now moving in a circular path. The result is a circular path that gets smaller as the wave approaches the land because the wave there becomes weaker and weaker at it as it approaches the land. Why? Because it actually touches matter. There are a lot of factors that weakens the wave. Water moves form because of the friction, or water waves form because of their friction between the wind in the upper part at the sea and the water. Energy from the wind transfers to the water as the water moves towards the land. Like all waves, water waves only transport energy. Because the waves move only through matter, water waves are mechanical waves. It cannot actually travel through empty space. Because the medium there, what is the medium there in water waves? What is the medium there in water waves? We have what? Water, yes. Water and because this is a combination of transverse and what? We have water and air. Okay? Make it circular in motion. Or wind. Correct. Correct, Hermoso. Correct also, Keisha. Okay, let's move forward. So this is now your wave characteristic. As you can see, your air actually is moving towards this area here, towards the right. Okay, as it moves towards the right, it actually reacts or friction actually reacted on water, creating waves. Okay, at the same time, water also is moving up and down. That's why it is now creating a circular path or motion. Okay, just like this one. Okay, let's move now to seismic or seismic waves. Okay, when layers of Earth's crust suddenly shift, an earthquake occurs. The movement of rocks send out waves that travel to Earth's surface. An earthquake is called a seismic or seismic waves. Seismic waves or seismic waves are mechanical because they move through matter. They only move through matter. Okay? Without matter, it cannot actually move or there is no waves at all. Okay, as you can see, there are three types of seismic waves. You have P waves or primary waves, S wave or secondary waves, and the surface waves. Properties of waves. When scientists describe waves, they describe the properties of wavelength and frequency. Okay. When you say wavelength, the disturbance between the point of one wave, such as crests, at the same point the next wave is called wavelength. Okay, from crest to crest, from throw to throw. The different types of wave can have a wavelength that range from thousands of kilometers to less than the size of an atom or atomic sizes. How about frequency? Sure, how about frequency? Sure. The number of wavelengths that passes a point of each second of the wave's frequency. The frequency is measured in hertz. Okay? Again, the number of wavelength that passes in a point in every second, okay, per second. So how many waves or how many wavelengths can pass through per second is called a frequency and is measured in hertz. Okay? 1 second is equal to 1 hertz. The longer the wavelength, the lower the frequency. As the distance between the crests gets shorter, the number of waves passing a point of each second increases, nagkadaghan. Okay? Wave speed. Wave speed depends on the medium or media or type of material through which it travels. Electromagnetic waves always travel through empty space, just like what we had discussed a while ago about ultraviolet rays. At the same speed of 3 by 108 meters per second, that is equivalent to 300 million meters each second. These travel slower through a medium or a mat because they must interact with the particles of that particular medium. So it depends upon the medium. Mechanical waves also travel slower because matter because the waves transfer energy from one particle to another. For example, sound waves travel about 1 millionth the speed of light. The speed of water waves depends on the strength of the wind that produces them. So it depends upon the medium if it is a mechanical wave. Amplitude and energy. Again, let's go back. Why is it that mechanical waves um move slower or depend upon the medium it is used? Anybody? Why? Again, I repeat the question. Why is it that mechanical waves move slower or depending upon the matter the media that is actually being interact? Why do you think so? Because again, mechanical waves needs a medium in order to travel. And again, these mechanical waves needs to interact to those medium in order to travel. Amplitude and energy. The wave's amplitude, what is again amplitude? This is the distance between the central axis, the center of the wave going to the crests or going to the throat. Okay, that is your amplitude. The wave's amplitude is the maximum distance of a wave varies from the rest of the position. You still have 1 minute left. For mechanical waves, amplitude is the maximum distance of particles of a medium move from their rest positions as the wave passes. The more energy a mechanical wave has, the larger its amplitude. Okay, nagkataas ang amplitude if it has more energy. Just like this one, okay? You're going to look at your amplitude. The longer or the bigger your amplitude, the bigger also your energy. Okay? Let's stop to amplitude and energy. Let's continue by next meeting because it is less than 1 minute now. And I think we have tackled a lot. Let's continue the discussion by next meeting. Thank you for your participation. Hopefully, you are also complete by next meeting. Okay? Thank you for your participation. Grade 7. Have a nice day, everyone. Goodbye.